All right. Hello, everybody. Thank you for making it for the panel event today. We are really, really lucky to have a great panel here for you guys across 3 universities, 4 or 5 disciplines. Yeah, and we can't wait to get into it, and we'll have an opportunity to ask questions at the end. So I'll ask you all to take your seats. All right. So in no particular order, I'd like to introduce our panelists. To my left here is Dr. Maxime Doyon. Dr. Doyon is a professor of philosophy at the Université de Montréal, author of Phenomenology of the Norms of Perception. He sits at the powerful intersection of phenomenology and cognitive science. At the far end there is Dr. Shahab Bakhtiari. He's the assistant professor at the Université de Montréal and associate academic member of MILA. The Quebec Artificial Intelligence Institute. Dr. Bakhtiari leads the Systems Neuroscience and Artificial Intelligence Lab, or SNAIL. Dr. Jelena Ristic is a neuroscientist, author, and professor of psychology at McGill University. She is a leading expert in social cognition, cognitive neuroscience, more than 125 scientific publications in international outlets. Dr. David Morris is professor and chair of philosophy at Concordia University. His main interests are in phenomenology, in particular the work of the philosopher Merleau-Ponty, with a focus on the philosophy of the body, mind, and nature in relation to current biology, physics, and science. And last but not least, Dr. Elizaveta Solomonova is an interdisciplinary researcher at McGill University's Neurophilosophy Lab in the Division of Social and Transcultural Psychiatry. Dr. Solomonova is interested in neuroscience and phenomenology of conscious experience across sleep and wake states, including dreaming, hallucinatory phenomena, parasomnias, and altered states of consciousness. Please give them a warm welcome. So, as much as cognitive science is a field, it's also an umbrella for many, many fields. And in each field that you all represent, there are many subdisciplines that are not necessarily tied to cognitive science. So I'm asking, maybe each of you in turn could tell us a bit about your path towards cognitive science and what sparked your interest in using the tools of your disciplines to study cognition. Perhaps starting with you, Dr. Doyon.
Okay, is this working? Yeah. Okay, yeah. So, first of all, thanks for the invitation. I'm glad to be here. Yeah, so I'm professor of philosophy at Université de Montréal. I work especially in phenomenology and philosophy of perception. I also teach epistemology and philosophy of mind. So I came to be interested in cognitive science a bit. I'm a latecomer, I would say, to cognitive science. I was trained in classical philosophy, mostly French and German philosophy. So I did my PhD at the Husserl Archive in Freiburg, working mainly on Husserl. And during my postdoc years, I did part of my postdoc at McGill and at the University of Chicago. And during my postdoc years, I started to work more seriously on perception. And quickly I realized that not so much the questions that I was pursuing, but the topics. So aspects like embodiment or context or various aspects of constitutive of perceptual experience are also topics of research from in neighboring disciplines such as neuroscience, psychiatry, psychology. So I started reading a bit more of the sciences through my research interest on perception, trying to get some new ideas, trying to challenge my own preconceptions, trying to find confirmations for philosophical views that I thought were interesting or compelling. So that's how I started to integrate more and more science into my philosophy and trying to, usually I try some kind of balance. You know, for me, philosophy is my home base, phenomenology more specifically, but I do my best to incorporate as much as possible philosophical insights into my own work, especially my work on perceptual learning, which is my new research topic. So, voilà.
On the topic of perception, I might pass it on to you, Dr. Ristic.
Hi. Yes. Hi, everyone. Thank you for inviting me. It is so nice to see all of you. I stumbled into cognition maybe by chance and luck. When I first took cognition as an undergraduate student, I was really confused by it. And I thought to myself, this is really confusing. If I ever understand a word of this, I'd consider myself to be smart. And then I somehow fell into it. I was at UBC. I was studying with Professor Alan Kingston, who was part of a group working with Michael Gazzaniga on split brain patients. And Michael Gazzaniga was one of the pioneers of cognitive neuroscience as well, sort of the imaging methods. And I was really fascinated by the way that we were able to sort of apply these cognitive models, these dry models that we learned and about in books, and then to really test them on neuropsychological patients and test them using neuroimaging. And in my own work, I have researched, I'm experimentally and classically trained, if you want, cognitive psychologist, experimental psychologist. I worked a lot on models of cognition, specifically attention and perception. And then in my work here at McGill, we have started to extend that into the role of cognition in complex behavior, specifically social behavior, interactive behavior. And the work from my lab and the others has shown that cognitions, in fact, are fundamentally changed with reciprocity interactions. And so this is opening a very new area of research in which we need to understand not just how the brain sort of passively takes input and computes these things that we're able to measure with our tests and neuroimaging methods, but also how are those perceptions and cognitions and understanding changed in or modified in interactive contexts, whether that be social interaction or interactions with objects. So I'm very happy to be here discussing today.
Dr. Morris.
It's wonderful to be here and to see so many young people who are setting out on new voyages of discovery and presenting really exciting talks and information today. My paths to this panel are kind of haphazard. I set out wanting to be a marine biologist, and at the same time in high school, through various miscommunications to friends, I was realizing that language is in fact quite important. But the sciences weren't going to tell me anything about that. And I found this weird book, the Tractatus Logico-Philosophicus, at a garage sale downtown. And I'm going to read that. But I did go into marine biology, and the biology courses were awful. It's just like, take this and eat it and then spit it back out. And I skipped most of the classes and got a B+, but the philosophy courses, those were challenging. I was like getting C papers and stuff like that in the beginning. And I thought, okay, this is what I want to focus on. I'm going to stick out with this. But then it turned out I went on to graduate school for some reason that I still don't understand. And went to, there's a class on Merleau-Ponty's phenomenology of perception. And there I found a philosophy that was taking on board and doing work through and with and working in and against sciences, and that really just hooked me forever. And it still seems to me, I tell my students this, that I don't think you can do philosophy well and honestly unless you have some other kind of interest, whether it's in science or in art or in literature, something against which you can ballast and check your thinking. Because I think that's the whole point of the phenomenology that I'm in. Merleau-Ponty puts it very well in a radio interview that my whole effort is to consider the concepts that I'm accustomed to using and that we're accustomed to using and check them against the realities they're meant to designate. And for me, that means that the way I usually do philosophy is by reading other stuff. So for the last 10 years, it's been quantum mechanics. But at the same time, perception and cognition are really important there because they tell us something about what it is to do science. And I don't think it's possible to do science or philosophy well unless we include reflections on ourselves and how we do this inside the picture. So this morning, the external versus internal science that Professor Tononi was talking about, this is an example. And this is, if I have one thing that I get to say here on this special occasion, is keep yourselves honest by asking yourselves how you're doing your science, and not doing your science from within science merely, but checking it against the phenomena that you learn about from people like Professor Ristic and Solomonova.
Dr. Solomonova.
Is this on? Yeah? Hi. Thanks for inviting me. I'm very happy to be here. And it's so nice to see so many familiar faces. This sounds very, like I'm at home. Okay, so just like all the other three distinguished cognitive scientists, philosophers just said, my path to cognitive science was also kind of serendipitous and somewhat haphazard. I like to say that I've had an interdisciplinary path, but things kind of open up a little bit randomly in reality sometimes. I did my bachelor right here at McGill in art history and religious studies. And then, completely by accident, coincidence, I don't know, whatever, stars aligned, I found a summer job in a lab that was studying dreams. And there was a kind of a weird moment because they were all neuroscientists. I was a humanities student. And, I was like, well, this sounds cool, teach me. And stayed there for the next 15 years, right? So then I did a master's in experimental neuroscience. Meanwhile, I started hanging out with philosophers and artists and other kinds of people. And I thought that, I have to go back to humanities, but I want to keep doing experimental work. How can I do that? And then I encountered work by Francisco Varela, and I realized, oh yes, I can do something like that. That sounds amazing. And so I did an interdisciplinary PhD where I had three advisors. I had an artist, a philosopher, and a neuroscientist as advisors. One would say too many cooks. I would say great parties. So I ended up having a PhD in philosophy and psychiatry. And I was studying dreams there was an ambitious idea. I don't think I solved any problems with my PhD, created more problems for myself. But I wanted to study dreams from embodied cognition perspective, from 4E. I wanted to do philosophy. I wanted to do an art installation. And I wanted to do a neuroscientific experiment. It did take 7 years, but I did do it. And my first real serious foray into philosophy was you, David, in your class, Phenomenology of Perception by Merleau-Ponty. That was my first ever real serious philosophy class that just blew my mind in more ways than one. And so now I'm at McGill in the Neurophilosophy Lab and in the Division of Social and Transcultural Psychiatry. I'm also an affiliated professor at Concordia in psychology. I teach classes here, as some of you know, on sleep, and at Concordia on culture and emotions. So many different interests and lots of overlaps with what my colleagues here are doing. Thank you.
And last but not least, Dr. Bakhtiari.
Okay, hi everyone. Thank you very much for the invitation. I'm so happy to be among you and also in this beautiful place. So I'm Shahab Bakhtiari. I'm an assistant professor at University of Montreal, Department of Psychology. And in my lab, I run research at the intersection of neuroscience, cognitive neuroscience, and artificial intelligence. And basically what we are aspiring to do is to discover shared principles of intelligence between biological systems and artificial systems. And in particular, we have been looking at visual capabilities and visual motor capabilities. What are basic principles that give animals these capabilities, and also what if those principles could also give us artificial intelligence. So my path, similar to many here, has been quite twisted and haphazard. I did my undergraduate degree and master's degree in electrical engineering, and the honest opinion that I have from that period is that I didn't really like it. So I tried to stay away from it as much as I could, And what I really, the farthest that I could get from electrical engineering, and still getting a degree in electrical engineering, was to do control theory, which is a branch of electrical engineering that involves all sorts of computational and mathematical theories on how we can control systems in order to kind of like, control them in order to get to desired states. And basically, so many courses that we had around that time and projects that I was trying to be involved with as an undergraduate student had to do with different techniques, and one of those techniques was reinforcement learning. And I learned very early on that reinforcement learning was a lot inspired by the brain. Now, in hindsight, the amount of inspiration was quite small, tiny, but still, that really got me interested in understanding what brain in particular and what we know about the brain can create better methodological approaches in engineering and also artificial intelligence. So when I was done with my so-called electrical engineering degree, I applied to different places and I got into a neuroscience program at McGill. And there, I really tried to forget about my engineering background. I really tried to be a classical system neuroscientist. So I did everything that a system neuroscientist was supposed to do, which was, collecting a lot of data, designing experiments, analyzing data. So I was happy because I could use some of those techniques that I learned in engineering to analyze data and so on. But what I really wanted to understand was the point of view of a neuroscientist and a cognitive neuroscientist. And I could say that I was lucky to gain that perspective. But around the time that I started my PhD in 2012 at McGill, the coincidence was that it was the year that it was the AlexNet moment. So in AI, AlexNet moment is very famous. It is the moment that the model so-called AlexNet was invented, and that was the moment that people started looking again into artificial neural networks, and now a domain that started to be called deep learning. And my whole PhD was kind of under the shadow of these developments in AI, because I started thinking about, one of my projects was thinking about motion perception, how brains do motion perception, dual pathways, etc., that many of you know about. But at the same time, we knew that these kind of things are, at the same time, being learned by artificial neural networks. So I started switching in the last 2 years of my PhD. I started looking into how these capabilities could be learned in a distributed neural network system. And I started, learning about visual perceptual learning, running experiments, modeling these processes. And once I was done with these topics in my PhD, I wanted to really go into AI and now, kind of like go back to my origin as an undergrad student. And there I started doing a postdoc at MILA, the Quebec AI Institute, and there I really started working at the intersection of AI and artificial intelligence, trying to see if these two systems could be aligned and whether we can get inspirations from one to understand the other one, and like both directions of knowledge transfer. So that was basically my journey, and I'm still trying to do the same thing, focus on different questions.
Thank you so much. So I heard the name of Merleau-Ponty come up twice, and I'd like to touch on something you said, Dr. Morris. You said that his philosophy wanted to work with and against science. Now you're flanked by experimentalists. I'd ask that you elaborate maybe a bit. And I put my cards on the table. I come from a neuroscience background, so I'd love to hear more on this.
Okay, I've never said things like this in front of such a crowd. I mean, I think the point is to be, look, the phenomenology that we do was set up by Edmund Husserl, who, he's an extraordinary person. All he really wanted to do was math, but really well, like figure out how you do math, what mathematics means. And in order to do that, he invented this whole new discipline of phenomenology to study how we cognize math, because he thought it couldn't make any sense to say that 2 plus 2 is equal to 4, take that seriously, if that was just due to some sort of psychological principle of how the brain works. You need to understand this in terms of structures of experience. And this just requires what he talked about as rigorous science, trying to know things with ever more rigor and with ever more discipline. And I think what we can talk about fruitfully is the way that there's sort of a tension within science between needing to advance within existing processes of discovery and just accepting the conceptual and methodological frameworks and the principles underlying those as what enable us to go and do our scientific work. And then through that very activity, here's the thing that I like. Through that very activity, finding that when we try to take it up in relation to the things that we're interacting with and experimenting with, those things themselves resist the ways in which we want to conceptualize and think about them. So I'll just give you one little example of that, and then maybe I'll try to take this back to Merleau-Ponty. But I know that Professor Bakhtiari and I have some kind of shared fondness for the ecological psychology of J.J. Gibson. And how did J.J. Gibson get his start? Well, he got assigned by the American Air Force to figure out how it is that we can improve the performance of pilots trying to land on airplane carriers in the middle of the ocean. And he realized that if you try and analyze this in terms of the pilots trying to sort of 3D model in their head where they are and where the aircraft carriers are amidst all the waves, that's just ludicrous. That's like no system would evolve to solve the problem that way. He realized that as the pilots fly toward the aircraft carrier platform, the sort of not parallelogram, I forget exactly what you call it, but there's a flow of visual information. And what the pilots are doing is just keeping themselves oriented toward that flow in such a way that they land correctly. They don't have a model in their heads of what it is that they're landing on. They have a way of interacting with the flow of visual information. This leads him to a concept of affordances as, well, this gets controversial. This is where the philosophy comes in. Just what does he mean by affordances? He's trying to talk about how what we interact with affords us doing certain things with them and relating to them in certain ways. That's an example of somebody who's working with the scientific procedure and realizing, I have to rethink fundamentally what it is that perception's about. It's not about reconstructing objects. It's about interacting in efficacious ways with affordances. And Merleau-Ponty is somebody who's arriving at similar points through different means, where the whole point of phenomenology, the rigorous science, is questioning our presumptions down to the most fundamental levels about what it is that we're doing. So to give you something that hooks onto this, Gibson, he doesn't work through this rigorously enough, in my opinion, but the whole thought that there's a subject over here interacting with an object over there, that's being taken apart by his concept of affordances. That's something that the phenomenologists Husserl and Merleau-Ponty are working at. And to hook this on to Professor Tononi's paper this morning, it's like he's saying we need to get what it is that we're trying to explain right in the first place, and then try to go to work explaining that. And I think Merleau-Ponty, I mean, this would get very complicated. I'm trying to make this easy and accessible for you, but it's just a very disciplined procedure for trying to work through in a reflective way a recalibration and revision of your concepts according to what it is that you're trying to talk about by allowing yourself to be open to the challenges of the phenomena. That's what I think is important. Resistance of things, running into the resistance of things and respecting the phenomena. So I call this a radical empiricism. It's an empiricism because it's open to what appears and taking instruction of that, but it's radical because it's using that to challenge the usual way that we talk about things. And that's where I think Merleau-Ponty is an absolute master, because he tries to read like hell through the results of the scientists. And then his way of putting it is, in the lectures on nature, he has this nice thing. The scientists are looking like for pythons and footholds to climb up the mountain that they need to get to do their work, but the phenomenologist needs to see. By that he means needs to engage with the rich perceptual context within nature where scientists are actually working. And then he says the philosopher needs to see behind the back of the scientists to what it is that they're not always willing to talk about. So some scientists go all the way with revising things. I think Professor Tononi is trying to do this. Einstein is trying to do this. Probably other scientists are trying to do it. But just like, oh, like if I'm really trying to work on this, then I have to start thinking about things in a new way, and I'm just going to have to accept it versus holding on to ideologies. So that's my shtick for Merleau-Ponty. That's my pitch for phenomenology.
Thank you. Thank you. And there's this sort of organic connection we've discovered with you, Dr. Bakhtiari, this idea of sort of this aspect. I'm wondering if you could touch on how those sorts of same ideas of ecological psychology also work into your own work. And also, when we think about thinking across disciplines and doing this sort of interdisciplinary work, how could we overcome some of the challenges that come with that? Because I think all five of your careers are sort of working at these intersections, and the system is not necessarily set out for this sort of work. So maybe you could touch on this as well.
Yes. So these are very interesting, topics and questions to address. So the reason that I personally got interested in ecological psychology and ecological neuroscience was actually the lack of these concepts in current AI. So the way that if you look at the best AI models that exist these days, many of us use them in daily basis, as ChatGPT, Gemini, Claude. These are multimodal artificial intelligence systems. But when you look at how these models are trained, you actually see that they're extremely deprived of experience, in the sense that, so I will just give you of course, a cartoonish view of how a large language model such as ChatGPT is trained. So they are given a very large corpus of text, and what really this model has to learn is to predict, given a set of words or tokens, so to speak, what comes next. So they're just learning to predict sequence of text. Or in multimodal models, they're trying to predict multimodal data. So tokens of text, but also at the same time, tokens of visual input, let's say. And what these models are learning is to really find how to project these modalities between each other, what this text corresponds in terms of visual content, let's say. So this is really unlike how animals evolve and how animals develop throughout evolution and development. And so this lack of experience, or learning through experience, or optimizing through experience, or adapting through experience. I'm using all these words because they're a bit different, but they kind of also allude to the same concept. So there's an organism, there's a system. It is exposed to all sorts of experience, and it is able to act in the world. It's able to move in the world. It's able to interact with the world. And this gap between how AI models are trained these days, or pre-trained, and how biological organisms, especially animals, have evolved and developed, it creates a gap in their capacities, or it creates a gap in how they really see the world. And so I will give you an example. We may come back to this later on, but one of the main challenges that AI has today is a spatial intelligence. So if you ask, go and try it by yourself. Try to open an instance of ChatGPT and try to communicate with ChatGPT via describing a space and trying to really challenge ChatGPT in navigating that space. Try to do back and forth with it, in the sense that, okay, I enter this room, there are some objects in front of me, and there is a door on the right side of me. Now I go towards the door, tell me where the objects are relative to me in this scenario. You will see that most of these models fail miserably in these scenarios. So there are benchmarks. There are like the ways that we test these models. And one of these benchmarks is called the spatial intelligence benchmark. An average human being performs around 85% on these spatial intelligence benchmarks. State-of-the-art AI models do around like 8% or 10% at most. So there is a huge gap, and my hypothesis is that this is not going to be fixed via continuing the same paradigm of next token prediction. We really need embodied experience in a world. I'm not saying in the real world, but in a world. And that is, I think, where we really get close to ecological psychology and ecological neuroscience. So there are efforts need to be done in order to really bridge between these two fields. And we can touch on those maybe later through back and forth. I don't want to talk for another 15 minutes, but there are like technical challenges that need to be solved, but also we need to align our languages. You know, sometimes we talk about same things in very different terminologies. So we do need to, this is a discussion we had very briefly with Dr. Morris, that we really need to find commonalities on how we think about these topics on the same ground.
Certainly, and it extends beyond how we train artificial intelligence models. It's also how we study, experimentally, I mean, it's how we study psychology, neuroscience. Often it's these highly containerized tasks and so on. And there's a question of ecological validity. I'm wondering, Dr. Ristic, if you might be interested in picking up on that point.
For sure. So I'm going to push it a little further from Gibsonian perception, which I think has really shaped the way we think about human brain, human visual perception in many ways these days. However, the human brain has not just evolved in an environment, it evolved in a social environment. And that environment is for sure embedded in a physical environment, but it's really what we see guiding our behavior on some very fundamental levels. So levels in terms of sort of numerosity perception, complexity of social relationships, group formation, rank order, familiarity of individuals. And we can take that from, you know, like dyadic interactions, like or small groups to maybe bigger groups to larger groups like societies. And so I think we know very little about how our brain, in fact, functions in that, within that sort of context. We know a lot about how it may function like an information processing mechanism, but we have little understanding on how it functions as a social organ, really, that is there to help us understand and relate to other people and not just land airplanes or, I don't know, interact with ChatGPT. And so ecological validity, you know, is a concept that we teach in psychology, obviously. And sometimes the concept is taken very sort of in a simplistic way to say, okay, well, how do we now take this, you know, pattern of dots and how do we make it ecologically valid? And so we'll say, oh, well, now we're going to make this, I don't know, buttons. So all of a sudden, this is a relevant object. Maybe, but maybe not, because real life objects, as we said, have affordances, but they also change the way we interact with them when they're in space versus not in space or on a computer in a 2D space. So there are very large challenges to ecological validity in experimental psychology. There are challenges in theoretical understanding of the mind. There are challenges in methodological ways in which we can, in fact, take our mind and study it in ecologically valid conditions. And we can take an example of fMRI as our gold standard of brain imaging today. It's a very ecologically invalid space in which the human brain can be imaged, and some have argued that, you know, most, if not all, of the activity that we see is just basically related to the fact that we're lying in this very noisy machine looking at some stimuli that are very static, and you can't move, you can't speak. And so there are very, very large challenges, I think, to ecological validity that at least psychology, experimental psychology, and cognition are facing these days.
Because if I'm not mistaken, it's this idea that, you know, our perceptions will vary depending on the environment, the social impacts, and so on. Perception is not there just to show us what's out there, basically, right? I'm wondering, Dr. Doyon, if you could pick up on this, sort of what are the things which influence our perception, or what is the task which perception aims to solve?
It's not an easy one. But let me start just by adding something that Dr. Ristic just said. So I'm also in total agreement that there's the social dimension is missing in Gibson's story. There's also another important aspect, and that's how I'll connect with your question, is also if we take seriously, as I think we should, that the mind is embodied and that perception is an embodied activity, then we're also, as embodied creatures, we have emotions, we have moods, we have affects, we're hungry, we're angry. So and this also impacts our perception. So the perceptual world is, it's not, it cannot be reduced just to like the brain processing information. You know, there's this dynamic with the environment, but this dynamic with the environment, this exchange or this coupling with the environment is done through a body that feels things. And with this comes all kinds of richness, but also of problems. So as a phenomenologist, I think this is a good thing because this allows us to enrich our descriptions of what perception is like. So Heidegger, for instance, insisted a lot on moods and so what he calls Stimmungen, you know, the profound impact of moods on perception. The social context is something that the early phenomenologists were really good at describing the impact of others and how yeah, it may change the affordances. Seeing things individually and seeing things when you're 2, 3, 4, 5 persons, it changed the salience of things. But with it, there's also challenges to in terms of the validity, as you just said, but also there are also challenges in terms of, well, it poses questions, for instance, like the jointness of attention. So the phenomena of joint attention is also a specific problem of how it is, how can we distinguish, for instance, that's something that interested me in my last book. So how is it that we can distinguish perception as achieved by an individual as perception when achieved together? From a phonological standpoint, so from a first personal standpoint, how is it feels like perceiving things together? So these are interesting questions, and then when we try to work this out in a lab or from a scientific point of view, then it raises other kinds of challenges that are more in line with what you guys are doing, because I'm more working on the first personal level. But yeah, so there are many more things to say, but I haven't even talked about the role of norms and how can this, again, both enrich and make the story even more complicated, but I'll leave it at that for the moment.
And you touch on this idea of being embodied. For most of us, I think, most of our time we spend embodied. But when we're dreaming, arguably that's not the case. And yet, we're still perceiving, we're still acting in some sort of way. I'm wondering, Dr. Solomonova, if you could touch on this idea, how we can use this special state to teach us something.
Yes, thank you. I think dreaming is embodied.
Oh.
I don't think it happens between your ears. I don't think it happens in the head. I think it is definitely, and sleep is a very bodily, very embodied state. In dreams, there's literal correspondences between, let's say, somatosensory experiences and brain activation, as really nicely shown by Dr. Tononi's lab, for example. Even if you're in a so-called deep sleep, if somebody touches you, you'll probably react. You know, somebody's monitoring the environment, somebody calls your name, you'll probably react as well. Even more so, so one of the studies I did during my PhD was that I wanted to see if dreams would react to somatosensory stimulation during sleep. So we put a blood pressure cuff on people's legs, and as they were sleeping, squeezed it, not manually, like there was a whole, we called it the kinesthetic stimulation apparatus. Okay.
Very naturalistic.
Nobody came in people's rooms, obviously. It was all done, experimentally through the wall and the rest of it. But basically, we squeezed people's legs as they were sleeping. And then asked them what they were dreaming about. And what was cool is that almost nobody dreamt about their legs being squeezed, right? What they dreamt about was, for example, somebody else had a broken leg, or somebody, was impeded in their movement, or, was a horse stuck in the mud, right? Or suddenly, there was one dream that was about a taxidermy museum, so animals stuck in motion, right? So the idea here was that, well, that's great, that means that the fact that there's not a direct correlation between the sensation of a body and dream content tells us something about the kind of extended metaphorical meaning-making process in dreams. Because, you could make an argument that, feeling of your leg being squeezed and then looking at taxidermy animals has something to do about impeding motion, right? Or, their leg is being, or, many people, and that sounds a little weird to say, but I'll say it, many people dreamt of me. Because right before they went to bed, we tried it with them, right? So then, they felt their leg being squeezed. They didn't quite exactly wake up, but they were just, oh, you were there, right? So it's a kind of this extended, metaphorical, associative, complex process of making sense of your reality through your body, right? That we often talk about in phenomenology, right? And in perception. And it seems to also works while you're sleeping as well. Plus, there's all the other idiosyncrasies. For instance, there's all this very cool and sensational work in lucid dreaming that's going on right now. When you signal from the dream with your eye movements, you can solve math problems. You can tap the Morse code of your initials. You can do push-ups and your heart rate will go up. You can, squeeze your fist and the same muscles will twitch ever so slightly. So we're absolutely not disconnected from our bodies when we're sleeping and dreaming, except for, and that's your second question, what can we learn from perception cognition from states like that? And I think this is exactly that kind of material. You can talk about, you can bring back the idea of metaphorical thinking. You can bring back the idea of extended thinking, of embodied thinking, of body actually shaping some of your perceptual and sense-making mechanisms out there in the world. And if it does so in sleep, it's very possible that it does so in wake as well, because it wouldn't make much sense for a brain to have like a special sleep cognition, program and a very special waking cognition program and a special before your first coffee program, right? Right. So that, I guess.
Okay, excellent. And as we think about extending our perception, extending our embodiment, if that could be said, what do you think that does to our cognition? What does it mean for us to do this? And I'll draw from a specific example. Within the last year, maybe year and a half, the first Neuralink devices were implanted in Canada as part of the clinical trial. Now, opinions about the particular company and sort of leadership aside, what does this idea and this emerging area of brain-computer interface shape or do to our cognition? Is it something we should encourage, something we should be wary about? And I invite anyone on the panel to share.
Before we go there, can I just make a comment about phenomenology and terminology and interdisciplinarity? I think it's it is very important for interdisciplinary work to come to common terminology. And just because this is my area of research, attention, I've heard this word spoken today many times, right? But the definition of attention scientifically remains in 1890s phenomenological definition from William James. That is basically his first person narrative of everyone knows what attention is. And in many ways, sort of interdisciplinary work first needs to understand and come to sort of equal level on terminology. And I found that through one of my projects where we're in fact working with the Department of English to look at patterns of attention during engagement with poetry. And so what we did for the first 6 months is just trying to understand what each of us is saying when we talk about attention. And we, in fact, have developed a manual with the literature and the reading. And so phenomenology, I think, in cognitive science, in psychology, and in experimental science as well, remains really something that stays with the experimenter, something that is always true, right, with the experimenter. And it's hard for us as humans to extrapolate that to second person or objective. It's hard to make that. This is maybe the limitation of our brain or our system, right? Extrapolating to second person.
Yeah, and even just within the philological tradition, it's also a highly complex affair. So, you know, just in Husserl's early work, you know, he works with two definitions of attention, what we would nowadays call like top-down or bottom-up attention. He makes this distinction. But then Merleau-Ponty, you know, criticizes Husserl's for having like the spotlight, working with this kind of spotlight metaphor of attention, and he thinks that Husserl is not taking the body into account, you know, not enough. He's not seriously building into the body in his account of attention, and there's also Gurwitch pitching in. Anyway, just within the phenomenology, I'm not even talking about philosophy, and then there's the other sciences, but just within the history of phenomenology, it's a very complicated thing. Nathalie Deprat, in recent years, tried to do some kind of cleanup and to update the phonological model, but yeah, it remains it remains a bit complicated. But I think the major issue now is still to how important the body, how important the whole body beyond the brain is in our account of attention. Is it, otherwise put, is attention really essentially or almost exclusively a mental phenomenon, or is it more than that? And if so, what are the incidents of that modification? So yeah, a lot of interesting works on that. Yeah, really interested in that.
Just to add to the level of complexity here, at the base of today's large language models, foundation models, so to speak, is the attention layer. And that is really funny because when you look at the formulation of an attention layer, you can't make any direct connection to what we mean by, let's say, top-down or bottom-up connection in cognitive neuroscience. So if, just, having been exposed to the stories of how an attention layer was kind of discovered here in Montreal at UDM by Joshua Benju and his students, a lot of it actually was phenomenological, in the sense that they really, through introspection, thinking, what are we doing when we are paying attention? Just the direct translation of what should be the process of paying attention. What is it exactly? Through that thinking, they developed a mathematical formulation of the so-called, back then it was a cross attention, and then later on it turned into a self-attention process. But when you look at the computational formulation of self-attention in a large language model, foundation model, it is really hard to understand whether there is a connection between what we call attention in neuroscience and psychology and what we really use as a mechanism in AI these days. So it adds just another layer of complexity.
If I can move this up to a sort of meta level, that I think, what we're doing now is we're using language to talk about how we use language, because we need to use language when we're doing philosophy and science. And I want to draw attention to, I didn't mean to say that, but I do want to draw attention to the fact that, in some kinds of contexts where we need to do rigorous work, we need to do it in such a way that we can agree on and settle and roughly define a kind of word that's central, so we can use it and agree upon it in relatively well-defined ways. And that's very important for many kinds of activities. But it's also the case that some of the most interesting and important results within science and philosophy and other disciplines come at the moments where there's a realization that the meaning of a word needs to shift, or we need to come up with new conceptual distinctions to make divisions between, say, top up and bottom attention. And in those moments, it can become very tricky, because the way I usually think of it is we need to refine or draw or create conceptual distinctions that are necessary for doing our thinking and analyses. And then typically we want to give names to the concepts that we've come up with. And sometimes we can come up with good names. Sometimes we come up with names like imaginary numbers. Like, the story behind why imaginary numbers are called imaginary is kind of strange, and it's just a bad word for what imaginary numbers are about. But it's also the case that, Maxime and I will be familiar with this, reading through philosophers where the same word is used to mean very different things, sometimes within one sentence. And this becomes, the paying attention to what attention means becomes very tricky when you have to attend to the way that the use of the word attention is itself trying to draw attention to itself as you track through different words. So it's just fascinating. That's part of what interdisciplinarity is: respectful communication across the differences between the usages of words. And the best kind of interdisciplinarity, I think, is the one where, through some kind of real time, even if it takes a lot of time, the words, we learn how to use words in different ways, or come to use them in ways that work across different perspectives. This is where I want to take your point about the social up to the higher level. This is what we're doing now, sociality through language as a way of thinking together in person on stage. This is where things happen.
Yeah, I think about this stuff a lot, because so part of my work right now in the neurophilosophy lab is with patients with psychosis. And of course, there's big contentious wars like delusions or hallucinations, right, that have a clinical definition, and they also have a kind of everyday meaning, right? Delusions mean you're wrong in thinking the thing you're thinking, right? Hallucinations mean the thing you see is not real. And these are really big, sort of commitments, thinking wrong things. What does that mean? Who's allowed to think wrong things? What kind of things are really wrong to think? By whom, right? So this is where the social kind of component comes exactly right back in, and these meanings that I get changed in translations. So there's a lot of sort of tensions between how we think about stuff in our disciplines, right? And then we try to bring it to another discipline. Turns out the same word means different things, and then we try to do ever more so granular definitions, and then it becomes even harder to keep track of what we're talking about. Then how do we bring back to our own discipline and use it in the way that we're used to using it, right? And then how do we go to, let's say, another culture? So part of my work right now is also through transcultural psychiatry, and I've spent some time teaching Tibetan monastics neuroscience, and that was opening a whole other can of worms, right? Even using words that we think are simple. I mean, we don't think are simple, but mind, consciousness, meditation, attention, right? You know, these conventional kind of realities, they generated so much pushback, you know, awareness, right? I don't know. I can give you a list of things, you know. So I'm wondering about how to go about those things, because on the one hand, infinite granularity I don't think is necessarily a solution, because then it becomes extraordinarily technical, and then you always need to kind of, you know, define everything you're going to talk about at all times pretty much and contextualize it. On the other hand, context is pretty much everything, right? So one should feel free in the context of their discipline to just use the words that they're used to using without always necessarily have to kind of stumble upon. And by the way, there's nuance, right? So that's one very important thing. So translation across disciplines, translation across cultures. Even if you're thinking about the same thing, turns out you're not. But I think also that reveals something fundamental about doing science, the fundamental uncertainty, right? It's not even about the problem of other minds, it's problem of words, right? Just generally. And I think that we just need to get used to the fact that it will always be a little ambiguous in a way. So then becoming precise within the tolerance of ambiguity, I think this is where maybe some generative stuff kind of lies. Yeah, I must say, I'm teaching courses on cultural psychology. You know, we spend two classes just trying to think about what culture might be, right? Or affect, or yes, consciousness, you know, another big word. Yeah, so I don't have any answer. I just have a lot of, not even questions, but just kind of curiosities. Yeah.
Can I add another thing?
Yeah, please, please.
If we are going too deep into this, you know,
Not at
just
all.
stop us.
Yeah.
But I'm biased, of course. But I actually think that working at the intersection of kind of neuroscience and AI helped me understand this point quite well, because there has been a lot of conversation in this space that I'm working in to try to take inspirations from cognitive science or neuroscience to build better AI in quotation. Okay, so now what is a better AI and so on. So let's assume that there are ways to evaluate this AI is better than the other one. But then the problem that most of us face in this challenge is that there is really there are so many difficulties in translating the knowledge from these domains to something that could actually be implemented and can actually do things that then we could consider as intelligent behavior. And a lot of it actually comes from what you're alluding to. There is a lot of misconceptions, but also at the same time a lot of ambiguities around topics and concepts that we use. And I'll give you an example. So one of the concepts that around that there has been a lot of debates and controversies has been the concept of representation. Yes, so it comes up so often in cognitive science, in philosophy, and in AI, and at the intersection of these domains. So people in cognitive science and philosophers, people from ecological psychology, they don't like this concept. They think that it is very ambiguous. It has so many there are so many misconceptions within this concept, and when we talk about representation, we actually don't know if we're talking about the same thing or not. So now, it's a very important concept. Why? Because these days, one of the problems that we have is the so-called the alignment problem. And it also gets kind of like it connects with the question that you asked about BCI, for example, brain-computer interface. So we use these models, these AI models, in different applications. We interact with them as humans, and we use them in applications that are quite crucial. Okay, they have consequences. They have social consequences. They have economical consequences, and sometimes they're really dangerous tools. So what we want to happen is that we want to make sure that they're aligned with our values. They're aligned with our or even simpler, they should be aligned with our space of perception. So in order to measure that, we use techniques that are now, called representational similarity analysis. Okay, they are very commonly used in neuroscience, cognitive neuroscience, and also these days in AI. So when we use these techniques, we come up with conclusions. We say that this model is more aligned with human perception than this other model. Okay, and then we start hearing complaints from, let's say, philosophers or from people from ecological psychology or other domains that, well, what do you even mean by representation? When you say that this representation is aligned with this other representational space, what do you mean exactly? And then usually people from more like technical, computational AI perspective, what the response that they give is that, look at this equation. This is what I mean by representation, and this is how I measure the distance between two representations, and voila, this is representational alignment. And that is actually the gap, because how, and I'm just assuming that I'm an AI scientist, but I'm not saying that I totally agree with that view, but if I'm an AI scientist, I don't want anything beyond that. I just want an equation, I can implement it in a computer, and it gives me a number. But when you really dig deep, there is a lot of assumptions built to all these equations that we need other perspectives to come in and tell us that, well, did you think about this? Did you think about that? And so on. And it is a very serious problem in our life these days. Just give you an example, a company like, Anthropic was building Claude family of models. They're spending a lot of money on giving personalities to these models. Okay, they are experts, probably psychologists or other type of experts, who are paid to create and shape the personalities of these AI models. Claude or Gemini or ChatGPT, when we talk with them, they have personalities, and these personalities are formed through specific processes. Within those processes, these metrics are used a lot. And if you don't really understand how these connect to cognitive science, or when we talk about them, are they the same concepts that we all understand, we will be into deep problems within the next few years.
So if I may add, just it's funny that, that you bring in a representation, because since we started talking about translation and the difficulties of understanding each other, I was thinking about representation as being the best possible example. So good. Just to give you an idea, in 1901, so it's very old text. Husserl says there's 11 concepts of representation at use at his time. So that's 25 years ago. 11, and discussing about that to so when few years after I got hired at Montreal, I was bold enough to want to make a seminar on representation. So we'll get to the bottom of things. So we're going to start with Husserl, these 11 senses, and then we'll see what are the major tendencies in psychology and analytic philosophy of mind, and I'll try to understand better the word. And I talked to a senior colleague and pitched my idea, and his response was, "That's the worst idea you've ever had." So I trusted him, so I didn't do it. But yeah, representationalism. So and this mass actually explains, in great part, I think, why in the people working in embodied cognition, they're split into two camps. There's people that want to explain representationalism in bodily terms, and others that just want to drop representations altogether. And a lot of people are radical anti-representationalists. So precisely in reaction to this total mess. So yeah.
It hurts me to do this, but I'm going to cut the panel here because I think we're going to have a lot of great questions from our students. And so I would invite, I think there are microphones around, so if there are any questions for the panel to answer, and you're welcome to ask the entire panel or an individual speaker. I see one back here.
Oh, hello. First of all, thank you so much for being here and sharing your knowledge with us. I think I had a question based on something I was hearing from your answers, which is kind of this implicit dualism in the way that we approach the sciences, approach the arts, see things as like external, internal. And I was wondering how we can break free from this kind of thinking, because I think there is like this consensus that we maybe don't really believe in Cartesian dualism, but it's still very much there, embedded in the way we approach our questions. So if you have any insights on that.
Um, I don't believe in Cartesian dualism. um, there's a question about art in there that I also think is worth using, and I'm just going to try and push that point again, because I think, look, here's the thing. Philosophy and science are done by human beings. And we come from a tradition, we come with a language, we come with biases, partly from what we've evolved to be, partly from our social environments, from our histories, and so on. And I think the thing about trying to think about the world rigorously and respectfully in ways that are going to be productive and thriving for human beings takes awareness of those limitations. We're never going to surpass them, but one of the limitations is a bias toward the mind-body and body world and self-other. Like, there's a whole plethora of dualisms. We could have a course on dualisms, cutting with representations and so on. But you brought up art in an interesting way, and your presentation, I think, was onto this, that the division between science and art isn't necessarily a productive one, because we can see that artists are also rigorous experimentalists, and the things that they do in their artistic practices are revelatory about consciousness and cognition, and also can bring to light very deep points about the body, but also deep conceptual points. So, I'm a Merleau-Ponty fan, but he's got a really excellent piece called Eye and Mind, where basically I think he's using Cézanne and Cézanne's practice of painting to make a point against Cartesian science. But it's not a point against all science. It's a point against disembodied science, what I call outside science, what Professor Tononi was talking about, extrinsic science, right? So it's sort of like the kind of engagement that you get with the artist that dedicates itself to responding to what there is in its own terms. That's a kind of thing from which science and philosophy can learn, and it can learn a great deal about getting rid of Cartesianism, because I think anybody who's been moved by a painting or has tried to do a painting or tried to do a dance realizes, like, try to do that as a Cartesian. You're going to fall flat on your face. You just can't do it. We just need to bring everything down to earth.
Yeah, thanks, Naya. So I think that a lot of contemporary attempts in cognitive science are actually directly addressing this discontent you're voicing. A lot of us and a lot of our colleagues are very aware of this issue and of this kind of unease, was the external versus internal kind of stuff. And I think some movements like embodied cognitive science already kind of decenter or create more porosity between, the self and its body and its environment, and where nervous system really ends, right? And how perception is not entirely just like computing external world into internal representations. But another thing that you brought up, Dr. Ristic, the social world, right? And the social world is a great example of this kind of porosity, right? What does it mean to make sense of things together, right? There's a concept in active cognitive science, participatory sense making, that Han de Jager and Ezekiel de Paulo have proposed, and I think it's really this is how science is done, right? Just like there's no culture of one, right? Or people say there's no such thing as a baby, baby plus caregivers plus other people, right? There's probably no such thing as science of one, right? Or philosophy of one, right? And doing this kind of activities, why not just sit at home and ask ChatGPT, what's the current consensus on Merleau-Ponty, Rather, why do you want people to kind of work through this together through questioning and through conversation? Is because there is this inherent porosity in all aspects of, I'm just going to use a big word, selfhoods or something, right? Trying not to use just attention or consciousness. Yeah. So people are trying to do this kind of stuff. A lot of this kind of dualisms are also just, historically we carry them over in the language, in how we've previously conceptualized science, right? Objective, subjective, that's already like a big problem, right? Science is obviously not objective, it's intersubjective, right? This is a consensus stuff that we do under certain kind of parameters of what we decide counts as science, right? So I think, moves to, including social phenomena and social cognition, making sense of things together, participatory sense making, embodied, cognitive science and embodied philosophy. All those are really, I think, strong attempts right now to actually deal with the question of, is there really such a difference between external and internal? Because you also can't say there's no difference between external and external. That would sound, make me one with everything kind of question. I don't know if that's, solves it, right? On the other hand, everything's internal doesn't seem to solve it either. But yes, thank you. It's a really cool thing to think about.
Thank you.
Maybe we can take two more questions. I see one in the back here.
Ben, I have a mic. Ben. Okay.
Oh.
Cool. So I'll ask the shorter one. That's
Sure.
yeah.
Sure, yeah,
Okay.
yeah, sorry.
Hi. Great panel. I'm sorry. That was really awkward. I'm sorry. So I'm in creative writing for science communication, like translating theories into something you experience as if it's like an imagination laboratory, as I'm sure you might be familiar with the Latin American physicists who do the same. And I'm wondering, would you ever, this probably wouldn't go for AI, but the complete abandonment of the pursuit of representation and the pursuit of measurement at all, and just talking about the phenomena, like how Eastern religions and Eastern cultures expressed their religious beliefs because they weren't really skewed for the pursuit of like converting or anything. And so a lot of their values or whatever are hidden between stories and metaphor. And that kind of created a sense of how they're so widespread and interconnected between like ancient Chinese and ancient Indian culture. So I'm wondering, specifically the person who talked about the Tibetan monks, I think it was you, would you consider a complete abandonment of your talking about neuroscience in the representational sense and instead talking about it more as Emily Dickinson would, as a poet would, just so you can reach them with metaphor, just as the way the Tibetan monks reach you with metaphor, because that is the way Buddhism is communicated. And I think that is the end of the question. I'm sorry.
Yeah, thank you. There's a lot to think about in your question. In my experience with monastics, they're not non-representational. That's the first thing. In fact, they have representations everywhere. Everywhere you walk, there's demons and things on fire, and samsara wheels, and taras and greens and yellows and whites and the rest of them, right? So I wouldn't say it's entirely non-representational. I would also say it's not. Okay. So Indian and Tibetan philosophy has very rich tradition of taxonomies of minds. There's kinds of things, there's kinds of virtues, there's kinds of percepts, there's kind of perceptions. It's very systematic, and in fact, not unlike contemporary cognitive science, right? In its approach. In fact, in my experience, Tibetan monastics were very much at ease with our methods of teaching. They would just disagree with us on the meaning of things, right? So they wouldn't disagree that we need to study the brain. They would just there's this classic story that everybody always talks about in Mind and Life. The first time Francisco Varela went to a Tibetan monastery, he put electrodes in a monk's head, and the monks are like, why are you putting electrodes on my head? And he's like, well, because, I want to study the mind. And the monks are all laughing. Why are they laughing? Because everybody knows the mind is in the heart, right? So it's not that there's not representation. The representation is different from ours. So the metaphor, what you're getting at, the metaphor is different. And this is where, stuff like or cultural competencies come to play, right? And there's a lot of interesting work coming out of transcultural psychiatry and cultural psychology about how to figure out how to talk to people about things that matter, right? So, for instance, in transcultural psychiatry, there's such a notion of as an idiom of distress, right? So, how, let's say, depression, how does one represent, in a way, I'm using the word, kind of literally, depression in the quote-unquote West, right? You would say, I feel down, I'm low, I don't have any energy, right? And they would tell you, well, that's because you have a, low serotonin, in your brain. So the metaphor is biomedical, the metaphor is through, neurotransmitter balance.
Yeah,
okay, great.
sorry.
But in other places, you may have a metaphor of a heart, right? Or a metaphor of a head, or a metaphor of something else, right? So that's where cultural competencies come into play for translation. So not a direct translation necessarily. Is that what you were getting at?
Kind of. I understand where you're getting at, and I've studied philosophy of science. This is my 3rd year studying measurement, and so I understand representations, and I understand the way that's used in the West and in science, but it's trying to take an abstract and make it more concrete, but it's always tied towards something that we think should be concrete, right? That's the entire problem of representation. That's what measurement's getting at. But I've also studied Hinduism and Buddhism, and I grew up in a culture where a mind, it wasn't even the brain or heart in anything. It was an abstract that we captured not for the sake of capturing it to prove that it was concrete, just to appreciate it. And so the representation that I'm getting at is, do you think that perspective or that pursuit to not try to prove its concreteness, but to embrace the fact that it's abstract and to truly relish in the fact that there is no right answer, but we're just embracing the way it makes us feel, the way it interacts, or the way, essentially, yeah, basically the way it makes us feel. Because that's, when I read Hindu literature and folklore, you're never really told X, Y, Z. You're told, you're not even told anything. You're just told a story, and it's what the reader takes from it. And yeah, I don't know if that clarifies my point at all. I hope it does. You can respond or cut me off. Whatever you want.
Yeah, no, thank you. I appreciate this. The question of how meaning gets created, basically, it is, maybe that's what you're getting at, and to what purpose. So, for instance, the purpose of neuroscience is, as we say, it's in the name, is to study the brain, right? It doesn't necessarily entail we're going to solve hard problem of consciousness tomorrow. It doesn't necessarily entail there's nothing else but the brain that matters, right? It doesn't necessarily entail a reductionism even. It's just that you're studying a brain, right? And then there's many ways to do this. There's so many ways to do neuroscience, right? Same way. So, for instance, those same Tibetan monks that I was working with, they're now building labs, and studying neuroscience. Not trying to prove that meditation works. They don't. That's not the question, right? But they're so curious to see how and what will happen and what changes and what parameters, And so that, I think, is not necessarily incompatible. But it's true that they're quite, well, let's say if you're a monastic living in a monastery, then your concerns are much less with a hard problem of consciousness than, let's say, for a lot of philosophers, right? So the concerns may be different. The translatability of those concerns, I think, it's possible. I can tell you, just from my own personal life experience and my own, I guess, value, I'm very comfortable with ambiguity, and I'm totally okay with not fully understanding what I'm looking at, So going to a monastery, they talk about something that I'm not entirely sure. I'm very happy to roll with it.
But would you be okay with accepting that you're not really looking at anything, that there's nothing to look at. And I think Ben is starting to look annoyed, so that would be my last follow-up question.
Yeah, I just in the interest of time, maybe we'll take one more and then we'll wrap up. I think, yeah. Oh, with the mic in the back there. Yeah.
Okay. I have a question for Professor Doyon. And I think you mentioned that the current AI lacks the spatial ability and they failed the tasks in benchmarks. So, but we seeing some embodied system like auto-driven cars. They seem to have like functional spatial awareness with their interaction of continuous multimodal environment. So do you think that counts for spatial awareness, or like, do you think there's any fundamental or qualitatively difference from the text, the training text, or static visual pictures, and compared to the multimodal data we have seen in train those robots?
Great question. And I think, yes, robotics in general is probably the closest that current AI is getting to embodied intelligence. But there is some fundamental difference still between how you train a self-driving car, for example, or the majority of robotic systems these days. Because of the fact, so there has been a lot of lack of improvement on the robotic side for many years. But recently, and by recently I mean the last 2-3 years, because of the great success of multimodal foundation models, large language models and vision language models, there has been movements towards exploiting the knowledge that already exists in these models in order to move things around, such as self-driving cars or robotic systems. So the device of a robot, the body of a robot, actually there has been a lot of improvement over the last 10 years. So these robots are really capable of showing all sorts of actions. So when you look at videos that come out of Boston Dynamics, the company, for example, you see that these models are really capable of doing so many interesting movements and very complex movements, but those are hardcore engineered movements, But the robot, the device itself is really capable of doing stuff. Now, over the last 2-3 years, I would say, people are started exploiting or taking advantage of the knowledge that exists in vision language models to come up with movement policies. So still the model that is being used to move these systems around, trained in the same way that you would train a large language model. In the sense that you just use the information that is inside a large language model, but use it towards moving a system around and try to fine-tune things so it works to some extent. That is one problem. The other problem is that most of these systems are trained in a so-called supervised learning fashion. So there is a lot of labels and a lot of data created by humans because people came up with a cheap way of creating data or exploiting existing data from humans. And all of these models are mostly trained to mimic humans. But when we talk about learning from experience, it is actually, we're talking about an agent that moves in the environment, experiences and acts in the world in a closed loop fashion. And when you really go towards that sort of approach, we still lack improvement. The current techniques are not as capable as you would, for example, see in training large language models, or any place that you're exploiting human data to train an AI system. So there is a gap that I still believe that needs to be filled.
If I can just add a sort of conceptual remark, I've written a book on spatial perception, and I think one mustn't get confused between the fact that the mobile autonomous car might be able to respond better to prompts that have to do with spatiality. Don't confuse the fact that it can do that with what's at stake, which is an experience of spatiality. And what I think you were talking about earlier. Sorry, I was getting it to draw. I can't draw. I tried to get ChatGPT to draw a picture of Husserl standing, looking at a table 4 feet away from it to the left. It just couldn't understand away 4 feet to the left, etc. And I don't think that, in terms of moving around, ahead, behind, left, right, away, near, far, these are the things that are crucial to us for our sense of spatiality. And I wouldn't buy it to claim that the mobile autonomous robot is getting spatiality in that way, even if it correctly responds to the prompts. So there's these conceptual points that are important, I think.
All right. Thank you so much. I hope you'll all agree with me that we could not have asked for a better panel discussion. I'll ask that you all thank our panelists with a round of applause. All right. Thank you all. Really, that was great. That was great.